And I'm going to mute my mic and stop my video, and you two are now in charge. Take it away, guys.
Let's do this, Dennis.
All right. Adhesives, direct metal repairs, right? Go ahead, Doug. Who are you?
So, who am I? Doug Craig, over 30 years in the automotive aftermarket, fell into it right out of college. Everything from general service garage to managing a body shop to service engineering at Chrysler, and now into the world of adhesives, all tied together. DB.
My name is Dennis Beardsley. I've been in the industry for 27 years. 23 of that has been professionally training. The last 5.5 years, I have worked for Saint-Gobain as an instructor. That is me. So preparation requirements, right? Very important. Any information that we want to find is at fuser.com. You can grab technical sheets, technical data sheets, standard operating procedures, and then OEM guidelines, right, Doug?
Yeah, it's really important, everybody. Most of this prep work talking about direct to metal applications and which ties a lot to seam sealing. It's like a one-time, right? You're going to learn once. Other than OEM stuff, which seems to be really, really volatile and fluid, so it's changing constantly. So those are the ones you're going to go out to the OE sites, really look them up. If in doubt, you know, we throw these links up. You can call in Diffuser. You can customer support at lord.com. Go to RSG at saintgobain.com. Put questions in, ask, make us work.
Absolutely. You know, we included the bead board right there, and I got one right here. Put it upright, and this will give you a guideline of, hey, can this product go to bare metal or can it not? And that's a good way to reference it, right? Where am I going, right? Some thinking alongside of that is, you know, pros and cons of direct to metal. Pros, right? We can all read it there. You can go faster, where primer could delay it. If the paint team must perform the priming, you know, the DTM products can be, you know, you can get it done quicker, you know, less bottlenecking. Right, Doug? What do you think of the cons?
I think it's really important to consider the cons. Everyone wants to go faster, quicker, but we need to make sure we're doing the work right. So my experience has shown me that the edges of sealers may not receive complete paint coverage, and that's just because of the angle of maybe where the sealer is at. It could be, you know, if you're doing a door skin and the door shell inner is kind of blocking the gun a little bit. We got to be real cautious that after we put the sealer on, we're able to get the balance of the system in place, that whole system, including paint, for, you know, ultimate corrosion protection. Another con I have found in a lot of testing, and that's of our own products, as well as, you know, I do go out and buy material and test other people's stuff. When you get into a harsh environment, and what I mean by that is, you know, an underbody area or an area subject to a lot of road splash, that's when you really do want a primer underneath just to give you that ultimate protection. Some sealers seem to be a little bit vulnerable to moisture moving through them, and they can have some corrosion over time. The other thing that comes up a lot is you'll see seam sealer thrown on real fast, but the paint prep wasn't done first. So now the painter's got to get in there with his fingers really tight and try and work out the little details, the grinder marks, you know, to try and make the door look perfect, or the deck lid, or whatever someone's working on. But the biggest concern I have when we talk DTM and folks get in this DTM mentality, there are some areas and products that require priming. It's just mandatory. And when I say priming, I'm referring to a 2-component epoxy, not a traditional rattle can. There is some 2K primer out there that works fantastically well, actually, not to sell their product. But, you know, up roofs on the F trucks, those are the areas where you get these small mistakes and they turn into just huge repairs later on, you know, reworks, etc.
Okay. Go ahead.
So prepping, right, is always the key. It's part of the overall repair process. Clean, clean, clean. We all hear that all the time, and it's like you preach it, but clean down the repair area before you even start working on it. So make sure you've got any greases, wax, silicones kind of out of the way so we don't have to deal with it down the road. Then obviously get the old adhesives and sealers cleaned up. If there's corrosion, slow down, take a second, make that go away, because you're not going to seal it down or cover it up with something and have it just mysteriously never come back. A lot of times you see repair work, grinders can slip, we know that, it happens, you know, but try and keep everything small. Any place you're removing coatings, keep it tight to the actual repair so we're not doing a lot of secondary work later on. And while you're there, feather edge.
Absolutely.
There's a lot of combat between the the body side and paint side. Takes a couple seconds, smooth it out, man.
Absolutely. I mean, you know, even the grit, right? You even see in that picture, that's that's an 80 grit. You know, that's what the OEMs want. Anywhere from a 60 to an 80 grit. That's what you do. To your point, right? That's what we need.
We don't see a lot of 36 grit anymore, other than maybe sharpening lawnmower blades.
That time of year.
Yeah. And on that slide, there was one last point which ties into what we're going to discuss more. There's a lot more spray applications, be it with one component products or two component products. But something really important, you know, these products do in fact stick to bare metal extremely well. They do protect the metal, but what we see in a lot of spray applications is just a real quick coating. You need to put some material on and then take a spreader, a rag, a brush, whatever you want, flatten it out, get 100% contact with the substrate, smear it around, then come back and put whatever your texture is. That way you know that as the material's building up, there's maybe not a water path down to the metal that'll cause corrosion. This just gives you the perfect repair.
Yeah, it ensures it, right?
Yeah, I know you and I have talked about this.
Absolutely, we have. It's it's critical, right? If it's just the seam seal or just the color, and there's nothing else, we don't need to paint it there. We can't give it any opportunity for corrosion to sneak in there.
Yeah, and that's an area, Kristen will chime in later on when we do some chit chat. If you're uncomfortable with that, then prime it, and then put your texturing on. That's perfectly acceptable, and it's what I would personally consider the best way to do it.
When we talk about primer, not to jump on that, just it's an important part, right? And I've seen a lot of priming and then getting on it too quick with seam sealer or over application, and you got to let it dry. You got to make sure that primer dries so it doesn't create an issue down the road.
Very true, very true. But it's again, we're always pushing the clock.
Absolutely. Trying
to get stuff done faster and faster. So, we talk about direct to metal seam sealing. Referenced if you're doing let's say, and we're going to touch on the swirl bead in a second, but doing some kind of spraying, again, put your material down on that seam, brush it out, spread it, and then put your finished bead down. Whatever the shape of that bead is, there's so many now to duplicate. But you're applying this stuff both to duplicate what was on the car from the factory, what the OE did, or maybe you're creating a sound control measure. Maybe there was a NVH pad inside of a door. You're going to duplicate that, or seen some of the stuff used to eliminate oil canning when the metal wasn't shrunk right. Kind of a last-ditch effort. But a lot of ways, a lot of tools, a lot of products. And it always goes back to the looking up the SOPs and the TDS sheets to understand what your options are.
Right.
The swirl bead's been the hot one for a while, and if you look at this bead really close, you can imagine that there are some little porous holes in that in the bead. And that's why if we do an undercoat with the sealer, then put our texture, our shaped bead, our swirl bead over the top of it, we know we've got that intimate contact with the metal. But this picture also illustrates what I was saying about you're up against a bead, now you've got to do all your feather edging. And if this was a feathered first, it'd be a real simple one. This is going to require a lot of tedious hand detail. That or a huge coat of primer trying to bury it.
Right.
The one area where DTM does come in real handy is when you're doing weld sealings. You get the squeeze out. So you're using a sealer as if it were an adhesive. You get that squeeze out. You're not really that concerned because you typically in this application you don't have feather edging up next to the sealer. You got material squeeze out, you clean that up, and then it goes to paint. But primarily that's in the rear body of cars. Rear body is where there's a lot of gap issues. It's just how it builds up in production. Your tolerances build up towards the rear, and the design of the car allows for some, we'll call slip fit. That's really where you start to see sealing, and it could be awkward, very awkward to get in there in the refinish process on some of this, but still that's the challenge, right?
Absolutely. I mean, right there in the bottom, anywhere OEM weld through sealer is found. Well, I get asked, well, how do you know? If you take a screwdriver and if it's squishy, that's seam sealer. That's not a metal bond product. So, if it has squish to it, that's what it is.
If it's rock hard, you can kind of presume it's an adhesive. And again, we go back to what's the manufacturer speccing out. And if they're not giving you any information, now you've got to lean towards what's the safest exit of repair.
Right.
Yeah.
Bare metal applications, right? Anywhere. Floor, strut, core, trunk, inner wheels, aprons. You see the doors, windshields, you name it. That's where it can be.
I don't have a lot to say. It's all over the car.
Yeah,
right?
it sure is.
You run into this bare metal.
Yeah, wherever it is.
Direct to metal kind of an application.
Love this salt spray test.
Yeah, so this is part of the fun part of my job is that I've had the opportunity to have a lab, 50 feet away from my desk for 5.5 years, and in that lab, salt spray chambers and all kinds of stuff. So I could kind of play mad scientist, put things together, test our products, retest our products, look at the competition. Not as a sales pitch, just to be honest. When I've got to make a decision, is something direct to metal? This is where I'm going to go to make that decision. I'm going to validate. It's not just a guess. I want to see this stuff work. And if it doesn't work, we're just not going to go there. And we're going to insist on priming, right?
Yeah, I mean, look at the difference from the fuser side to the other stuff. I mean, that's big.
This is what you can see in tearing a car down 2, 3, 4 years later. And even though somebody was trying real hard, maybe the product just wasn't adequate. And if you don't know 100%, well,
there it is.
You've got options. You got priming options.
Right. Different products that can do the same thing, right?
Yeah, this slide, we're just kind of wrapping up, I think, what we've been saying.
Right.
When you go down the direct to metal sealing path or the bare metal products, this is what can be expected. Again, over on the right, testing I've done, with our stuff against others, and it's interesting. You see on the right side, the top picture, those little spots, those two little pieces of material have got spots on them. That's rust. It's after 500 hours in salt spray, and this stuff is starting to really corrode the material. So it's all the design of the product. What is it really coming from? And, you know, trying not to make this an infomercial, everybody, so don't hate me for it, but understand this is where Fuser is different than pretty much everything out there. Is Lord is a structural adhesive company, and that's what we make. Fuser is a derivative, so we're bringing in structural adhesives and using them as seam sealers or as other components. So generally, kind of crazy robust.
Sure is. Sure is.
Right. So again, just another, you know, once you've got all the base information, and Dennis started with the bead board, this is just another way to illustrate the same information. You know, some products are not required to have primer. Some are required. That includes foams. That's another area. You really don't want to be putting foams over bare metal. If you can't get in there and prime them, then you need to do a cavity wax before you put the foams in. Probably the biggest area that is a problem are self-leveling sealers and roof ditches or similar areas.
Right.
They require cured epoxy, right? Because those joints flex. It's on the top of the vehicle, and the top of the vehicle is in torsion. It's going to move around. It needs, every layer needs to be really well bound and tied together. The other area, there's always a little bit of confusion. Controlled flow is my favorite, right? This is the one that you can do tape edging, spread it, pull it all up, and everything just rolls off and looks factory. But you don't necessarily want that everywhere. Somewhere you may still want to see a brushed application. And that's where 1Ks, 2Ks, you got to use the thicker non-sags to get that. The vast majority of all the products we're talking about do have this bare metal, direct to metal capability, right? And that's really what this is about. What your end result looks like is the pick of the product.
Yeah, I mean, you can make all sorts of cool designs. You can comb it. You can, use the air to get all sorts of different ripples and designs, messing around with your air and fluid delivery, right? I mean, it doesn't look like it was put on by my 9-year-old, right? It just, there's a little work behind getting that correct bead. And that's what we do a lot at our training center in Waterville, New York here.
It's art. It's art.
Sure is.
So at the end of the day, I'm looking forward to Kristen coming on here in a couple seconds, but when you got questions, reach out. There's a huge network of St. Gobain folks, of reps. You got the call numbers, email. Reach out for the information. Never have a question and just guess. That's how we get in trouble. There are plenty of people that are waiting to have somebody try and tickle them with a question that makes them think a lot.
Yeah. Good point.
Here I come, here I come.
I've been waiting for this.
No, I was just trying to be, so I've always made it clear over the years, I'm not a fan. I guess adhesive's a completely different, thing. We're going to brush that in real good. We're going to get into all of our areas. So corrosion needs a space to add oxygen and some sort of, spark chemical moisture, whatever that is, to corrode. And so, with my adhesive in my joints, I'm brushing that in. I'm getting a really tight seal or whatever. Seam sealers and some other things that we've listed as direct to metal in the industry are just so commonly misused. They drive me crazy. So we get those gaps, and then that corrosion starts to begin around those gaps, and that's been why I hate them. So when I do go out and work with shops, I tend to go, no, we're not using these. We're going to go back to epoxy. So, and then put something else down. You can use this over epoxy if you want to, but I know you guys see it when you're out with shops. You see that corrosive edge starting to form.
Oh yeah.
We created on coupons in the lab. The most recent was a product that was launched at a new application method, and ran it a couple different ways, and then threw it in the chamber to see what would happen. You've got to have that 100% intimate contact with the metal. If you have any gaps, yeah, it starts going crazy. And this is why, Kristen, I don't have necessarily the right word track for it, but what I'll call it your better quality shops.
Mm-hmm.
Generally, their SOP has them priming everything.
Mm-hmm.
That's just how they do business. They find a way around the bottlenecking, if there is a bottleneck. Why they want to be as confident in their repair as they possibly can. And, we're all human, so we can slip up. So you take steps to error-proof the situation.
Yeah.
And that's one of them.
We've gotten into this production mentality where we just kind of feel like we have to push cars through so fast. We believe all these products add speed, and at the end of the day, the repair is going to hold a certain way the day it leaves your shop. What we're really interested in is how the repair is going to hold 2, 3, 5 years after it leaves your shop. So if right now years of ownership is, I think the last report I saw were somewhere at 14 years of the average life of a car on the road. As a repairer, I am liable to the car. That's what I want to drive home to every shop. It's cool that you're giving a lifetime warranty for as long as that customer owns that car. That's your warranty. Your liability is for as long as that car is on the road, and that's part of what the John Eagle case. The Sheba Shans were not the owner of the vehicle that went to John Eagle for repair. They were the secondary owners of the vehicle, but the shop was still liable to the new owners for what was done to the vehicle. So if I'm working on a 2018, a 2017 model in my body shop today, I need to know that I'm going to have at least maybe 12 more years of liability of that car's lifespan on the road. And so corrosion protection is huge. And taking a gamble over a direct to metal seam sealer or something is just not a good wager. That's house odds in Vegas almost, but not a good wager for me as a small business owner. So, epoxy. Sure, it's going to slow you down a little bit. You got to let that epoxy cure. You got to, then go back. But 3 years later, when you're looking at that car through a microscope or through an attorney's eyes or whatever, it doesn't matter if you followed the OE procedures if the repair rots out. So.
Absolutely. And bring back in our last discussion last week, cavity wax, right?
Yeah.
This corrosion protection is huge.
Yeah. I think
factory gets.
I think for me, cavity wax is like that's my fix all everything. It's like just before everything leaves, does it have cavity wax? Before my kids leave the house now, I spray them in cavity wax. I'm hoping it's got some sort of corona benefits. I don't know, but it's just my security. And I still go in shop after shop after shop. And I love our field sales reps. I do. But I think sometimes the desire to sell a product doesn't necessarily mean we talk to them like technicians. Sure, I know what the label says, but I wouldn't do that if I was you. So it's my pet peeve. Jason, I notice the chat room's quiet, but as a tech, questions, comments, thoughts, concerns?
No, the only thing when it comes to overall corrosion protection, corrosion protection has always been paramount, but I think some of the one thing that I've noticed, with the steels getting thinner and thinner as they go to higher and higher strength steels, that corrosion protection becomes even more important because you got less material there that will corrode away, and the impact that collision energy management will have will be altered if you've got rust in there. So it's so important, it's so critical, and like you said, epoxy, cavity wax. Corrosion protection is vital more than ever, I think, now with these thinner materials.
Yeah, Doug, I'm going to take advantage of this moment to throw you on the spot. You're welcome.
Under the bus?
Yeah, on the spot, under the bus. If the spot happens to be under the bus, what can I say? I want to know those OEM days for you. Because I get this question all the time, and I think you're probably one of the best people to speak to it. Can you talk a little bit about how substrates have changed? You know, metal's not just metal, and how that's affecting repairability and even corrosion protection steps, like Jason said. I mean, panels are different but better. Does that make sense?
Yeah, I kind of feel like most of the industry gets it now, but it's just like Jason said, right? It's all about lightweighting. It's all about safety. As the metals change, become stronger and stronger, we can thin them down. That gets us the weight. But if you've got, in this discussion, if you've got a corrosion problem, your metal's now half the thickness what it was 10 years ago. Guess what? It rusts through way faster. You know, some of the stuff I've referred to as unobtainium or kryptonite, right? That's what's being put into the cars is new metal like that. And we've got to protect it because it is thinner, but also because it's being depended upon a lot more. Both safety, general ride quality. People expect a much nicer car today than they did 10 years ago, 20 years ago. It all bakes together. I don't claim to be a metaler, just you know, been around all these steels, and it's going to continue. And it's continuing heavy with aluminum right now, and I would anticipate within our life we're going to see way more composites, or just what I refer to as plastics. Different plastics are coming out every year that are thinner, they're more fiber reinforced. You don't even know it, you can't see it. Even plastics now have glass beads within the plastic. You won't see that until you fix a bumper cover, throw it in the booth, and all of a sudden you got this halo around your repair. Like, what was that? Guess what? You broke into a bunch of glass beads when you were grinding it. You got to be careful. Technology is going way fast, right? It's right there with all the ADAS stuff that's coming in. Cars are harder and harder to repair every year, you know, and it's fuel economy, safety, etc. Did I escape your question?
You did. Yeah. And I get the question a lot of times when techs are telling me more around fillers than seam sealers. When they're saying, hey, I always applied my filler direct to metal, never had corrosion problems. Now I'm having them. And I'm like, well, it's different metal. Things are just different. And I don't know if it's more susceptible to corrosion now, or there's changes in the filler that are, you know, when you leave that gap, it's charging that. But definitely things that we have to think about. I've gone to I don't do filler direct to metal anymore. I put epoxy down. So just so that I don't have those issues. A couple of questions that have come in. It says someone mentioned that soft products are seam sealers and hard products are adhesives, but aren't two-part seam sealers hard as well?
So two-part seam sealers are hard. It varies by the product. So the old screwdriver test is all you've really got to go by unless you've got some kind of documentation. If it's just a seam sealer, it's laying on top of a seam, obviously it's not an adhesive, right? But if you got that question, what's between a panel, is it adhesive or did they do a weld sealing operation? And it's really hard, yet there's no OE documentation, what are you going to do? You're going to probably lead and put an adhesive in there. Generally, when we're talking seam sealing, it's laid over a seam, with the exception of, you know, the rear areas of a car, like I was saying, where you start to get some gapping in the panels, and that's where they'll do generally expandable seam sealers between the panels, and those are real fluffy because you're just trying to control airflow and water intrusion. It's a tough question to answer 100%.
Yeah. So a question about seam sealing on new parts. If you're replacing new parts, do you need to epoxy beforehand? And I would, I want it two parts. One, just think of a brand new part out of the box, new hood, new door. And then also explain the difference between if you were doing a door skin, what the answer to that might be.
So if you've got a new part out of the box, I'm going to say a new OE part, it's going to be fully E-coated. You do not need to apply a 2K epoxy unless somehow you've damaged the E-coating. If it's an aftermarket part, I can't speak to what's on there. I just know for an OE, they're going to duplicate their E-coat on the service part. In an assembly process, the seam sealing is done after the entire body in white is E-coated. That's why you see service parts without seam sealer, because for them to have seam sealer, they would need to be feeding into the assembly line with the seam sealer on. Taking a service part offline and applying a seam sealer before you package it increases the cost of the part dramatically because it becomes a manual operation. It's also, you've got to have some staging of parts that are curing. So when in doubt, go ahead and put epoxy prime on. You're not going to hurt anything. Just make sure you seal the parts up.
Hey, we got another, actually not a question, just a comment here from Robert as well, making a great point with all the different materials that we're using, you know, the multi-material vehicles that we're going to start seeing more of, aluminum combined with steel, combined with composites, as you mentioned, Doug. You know, just the fact that dissimilar metals that, you know, again, using corrosion protection or some type of protection between those dissimilar metals also can play an important role to prevent that galvanic corrosion from happening and creeping in there. So yeah, definitely a great point there from Robert.
And if anyone has any questions they want to unmute themselves and ask, obviously feel free. Wear my Corona t-shirt and now I'm coughing. So,
Catch that.
how's that work, right? So just some important things to think about with, we'll see if some other questions come in, but with any of these products, one, OE procedures, always, you know, and then two, you need to have established SOPs in your facility for how you will handle these situations. So, I mean, obviously the manufacturers make products. I have my opinion based on re-inspections and court cases. And so I have almost like the chicken little sky is falling mentality, because if it could go wrong, I've seen it happen. But it's just very, very important that you have these established practices and that they're printed and that everyone in your shop knows what they should and shouldn't be doing, when they should and shouldn't be doing it, and what they should and shouldn't be using. And so if you want to, you know, do away with rattle cans or whatever to prevent that urge to go to them, then that may be something you have to do. Or if you want to have a checkout basis where you control materials and technicians have to check them out so you're not worried about something getting used when you're not looking. Lots of things to think about, because I really want to drive home to you that if you're working on a current year or a 2-year-old car, you have 12 years potentially of liability there. And when you think about that, when you put that in perspective of the repair, it's not just about delivering it back to the customer. It's not thinking about just how long that customer is going to own the car and how do I have to warranty it. You've got a lot of years that you're going to be responsible for that. And so corrosion protection is huge for you. It's way more important than I think we're giving it credit for in the industry right now.
Hey guys, I do have one more question that's not come up today, but has come up in the past for me. When I'm going through the OEM procedure and I've got a product that I'm using, that doesn't happen very often, but sometimes we'll see a little bit of a discrepancy between what the OE is asking for versus what the product maker application process is. How do I know when I should kind of adhere to the product maker procedure versus, you know, kind of what the OEM procedures kind of got listed when it comes to maybe not necessarily corrosion protection, but adhesive preparation or just general preparation when it comes to a product that you've got?
So we're always going to follow OEM guidelines. Why do they sometimes differ? It could be that the writer of the information didn't have 100% clarity. If it's incorrect, could be they've done a lot of research and found out they want things done slightly different. In the case of some of the European vehicles, they're trying to put procedures together that are so error-proofed they can be done anywhere in the world by an untrained person. You see a lot of variation. at the end of the day, what the OE says, if you deviate from it, then you could be held accountable. Sometimes it may be very difficult to impossible to determine if you did deviate from it, but start asking questions. I mean, even the OEs have got hotlines you can call to confirm technical information. So reach out and ask, and it may drive, you know, a flurry of phone calls and emails. That's okay to come up with an answer. Did you kind of hit on what you're asking, Jason?
Yeah.
Yeah, it does, and I think you made a great point because you know the OEs. I think in my experience with them, they have gone back and changed things and done more research on it, and you know perhaps a product that they developed a procedure on has changed, you know, over the years, new technology, new materials within that product. So they are willing to make some changes on it when it comes to that. And so if anybody on the call does run across something like that, you know, certainly can reach out to Kristen or myself, or use the Collision Hub Pick a Tech feature, and we've got channels up to the OEs to reach out to them. So if that's not a service that you're using currently today, we can certainly help you get in touch with those OEs on occasion to try to get those types of issues resolved.
One question coming in general. So the question, Doug and Dennis, is if a panel bond or weld-through primer is not specified by the OE, would it be acceptable to apply a single component weld-through seam sealer as a level of protection between the two panels? And so as you answer that, I think it's also a good time to maybe even talk about weld sealing in general, kind of a newish thing out there.
Yeah. So if there's nothing between the panels and the manufacturer's got no guidelines, the you know, a one component seam sealer is not going to add any rigidity or change to the overall vehicle structure. What you're doing is putting something between there that effectively seals out that whole area from any potential for moisture intrusion or salt intrusion. So it's fine. And weld sealing, we've started, I think really it became to the forefront of some marketing about 8 years ago was when it started being pushed. It's great for, like I say, these large gap applications where you know you don't have true adhesive in there to really seal off that whole, I'm going to call it a weld flange, for depending on what the joint really looks like, but you're just kind of sealing that whole thing out without changing the vehicle. Right? That's always our concern. We don't want to start doing things that could change the way a rail crushes or the energy pulse is detected for firing of the restraints. But where you see most of the weld sealing is ancillary panels that are the pretty panels, or they're the dust covers. You know, to me, a floor pan is more of a dust cover. It just keeps the mud off the bottom of the seat, and it's you're not going to change anything there, shy of playing around the structure itself.
And then there's another question in here. Are you aware of any 2K aerosol primers on the market?
I am. Spray Max is the only one I know.
Yeah. Spray Max kind of leads that market. Eastwood also says they have one. I've just never really seen them effectively used in a collision shop. So, you know, Spray Max makes an epoxy and also makes I've just never seen them used. And so yeah, but they're out there.
Yeah, just those of you that are interested, just go out on the internet and search Spray Max and go to their site.
No, it's like $26, $27 a can. Oh, it's pricing. Am I supposed to talk pricing? I don't know.
Yeah, we're not supposed to do that.
Jason, you see any more questions in there? Oh, RM has
so
yeah, Robert's in here. RM, so BASF has a 2K that's available. Look at an aerosol, and then BMW also has one as well.
And one question on seam sealer for weld sealing, Doug, can you use any seam sealer for weld sealing, or are there specifically designed products for that?
So when we get into talking weld sealing, we're talking resistance welding. The resistance welder doesn't care what's in between the panels. It will burn through it. So what we care about is that it's a non-flammable sealer. So a lot of the older, I call them older sealers, have a solvent base, and they will or can catch on fire. Urethanes, acrylics, epoxies, they're non-flammable. So while you might see smoke, it's not going to sustain combustion, and that's the concern. You know, the resistance welder does not care. If you've ever seen the old sales trick to sell resistance welding equipment was 2 metal coupons, put a plastic water bottle in between, and weld through the whole thing. The equipment just doesn't care that there's plastic there.
Excellent. All right, well, guys, thank you so much, as always, for coming through and presenting for us. It's my pet peeve topic, so I gave you guys a loaded gun and said, here, come present. So I appreciate you taking on that challenge. We are not done on this Friday. It is fairly a light day for us when it comes to webinars, but we are back here again at 2 o'clock Central, and we'll have Matrix One, or we're going to be talking about diagnosing and documenting structural damage on vehicles. So that should be a good one as well. And if you have any questions, obviously the guys have got their emails up there for support. You can reach out and get any questions answered. If you have any additional questions and you may be scared to talk to those two guys, well, you can always email myself or Jason. We'll be happy to take care of anything we can. Thanks, guys. We'll see y'all later.
Thank
Cool.
you.
Thanks, Kristen.